Imagine a moment so fleeting that it lasts only a few seconds, yet in those moments, the fate of nations could hang in the balance. Somewhere on Earth, in a quiet desert, on a remote island, or deep within a military test range, a rocket ignites. Its engines roar, blasting fire and smoke into the sky. To the naked eye, it may look like a simple streak of flame fading into the blue. But high above, invisible to everyone, a network of eyes in space has already detected it. Satellites orbiting the Earth register the heat, sending precise data down to command centers thousands of miles away. In less time than it takes for a human heartbeat to skip, analysts are examining the information, calculating the missile's speed, trajectory, and potential target. Every fraction of a second counts. This is the hidden world of missile detection. A silent system that is always watching, always calculating, always ready. The danger is real, but the danger is unseen. People around the globe live their lives unaware that, at any moment, a single launch could trigger alarms that reverberate across continents. But it rarely does, and that is exactly why this system works. It is invisible, seamless, and incredibly fast. Its purpose is simple: to detect any missile launch on Earth, as soon as it happens, to give governments the knowledge and time they need to respond. Yet the science behind it, the technology, and the coordination between human minds and machines is astonishingly complex. These systems rely on satellites equipped with infrared sensors that can see the intense heat of a rocket engine against the cold backdrop of space. They rely on massive radar installations that sweep the skies, tracking objects across vast distances. They rely on human analysts who interpret every signal, distinguishing between a harmless space launch and a potentially threatening missile. And they rely on decision-making networks that connect multiple countries, militaries, and intelligence agencies to ensure that critical information reaches the right hands. The suspense lies in the fact that none of this is visible to ordinary life. You do not see satellites silently circling above, nor do you hear the soft hum of computers analyzing heat signatures in real time. Yet these systems are on constant alert. Every launch, whether it is a peaceful scientific rocket or a dangerous weapon, is captured by these eyes in the sky. And for every detected launch, there is a silent question hanging in the air: is this routine, or is this a threat? Analysts must act fast, because some missiles can travel thousands of kilometers in under half an hour. Every decision, every calculation, every alert carries weight, and the stakes are enormous. The consequences of a missed detection could be catastrophic. This is not just about technology, it is about maintaining a layer of security for millions of people. It is about ensuring that when danger appears, there is already knowledge to meet it. The suspense comes not from what is happening on the ground, but from what is happening in the split seconds between detection and decision. The space where technology and human judgment intersect. The space where a single observation can make all the difference. In this hidden war of observation, time is the most precious resource. The moment a missile leaves the launch pad, countless systems spring into action. Satellites beam infrared data to analysts, radar systems track the missile's flight path, and decision-making teams start evaluating potential impact. Every stage must happen flawlessly, for a misstep could create confusion, delay, or worse. Yet, despite the incredible complexity and speed, most of the time the world continues on, completely unaware of the silent guardians orbiting above. The suspense is ever present, even in moments of quiet, because no one knows when the next launch will occur, where it will happen, or what it will mean. And that is the essence of missile detection. Vigilance that never sleeps, decisions made in fractions of a second, and a system that protects millions of lives without anyone ever seeing it. The story of missile detection begins far above the Earth's surface, in the cold and empty reaches of space. The United States relies heavily on a network of satellites that are always on watch, scanning the planet for any unusual heat signatures. When a missile launches, its engines produce an intense burst of infrared energy that is impossible to hide. Satellites equipped with the Space-Based Infrared System, SBIRS, and other specialized sensors detect this heat almost immediately. These satellites do not need to know whether the launch is friendly or hostile. They are designed to recognize the physical phenomenon of a missile launch itself. They see the bright flare against the dark backdrop of space, and within seconds, the data is sent down to Earth. This orbital perspective allows the military to detect launches anywhere in the world, from remote deserts to ocean test ranges, creating a constant, unblinking watch over the planet. Detection is only the first step. Once a missile is spotted, the information must travel at incredible speed to the command centers that make sense of it. Bases like Buckley Space Force Base in Colorado serve as the nerve centers for this process. When a satellite senses a launch, the data is transmitted almost instantaneously, and analysts begin calculating the missile's trajectory, speed, and likely target. The speed of modern missiles means that minutes, sometimes even seconds, matter enormously. These alerts allow decision makers to understand not only where a missile is going but also whether it poses a real threat. The entire system is designed for speed and accuracy, ensuring that no critical information is lost in translation between satellites, radars, and human operators. Satellites provide a global perspective, but they are only one part of the detection network. Massive radar systems stationed across North America and other strategic locations form a second layer of protection. These radars can track the missile's flight path with precision, offering a real-time verification of what satellites have already observed. This combination of space-based infrared detection and ground-based radar ensures accuracy and reliability. It reduces false alarms and gives the military a detailed understanding of the missile's speed, altitude, and trajectory. Together, these systems act as a comprehensive shield, capable of tracking objects through the atmosphere and into space. Technology is essential, but human judgment remains the core of missile detection. Analysts, intelligence experts, and military leaders interpret the data, distinguishing between test launches, scientific missions, and actual threats. Not every detected launch signals danger, many are routine events, such as satellites being deployed or missile tests conducted for research purposes. Experts assess the intent and context of each launch, using experience, historical patterns, and real-time data. This human analysis ensures that the automated systems do not simply react blindly but provide meaningful intelligence for decisions that may have profound consequences. The world of missile detection is evolving rapidly. New technologies including hypersonic weapons, low-flying missiles, and advanced drones present new challenges to existing detection systems. To keep pace, the United States is developing next-generation satellites, artificial intelligence systems to identify unusual flight patterns, and collaborative networks with allied countries to share critical data. The goal is not only to detect launches but to understand them more accurately and quickly than ever before. The future of missile detection is a combination of advanced technology, international cooperation, and continued human expertise, ensuring that the world remains vigilant against emerging threats while learning from the past.